Welcome back to Discrete Mathematics. Today we're going to look at solving recurrence relations with generating functions. So, specifically, we're going to work with an minus 3 to the an minus 1 is equal to n. Now, we can solve this with our old method. So, first we could find an is equal to anh plus anp, and we can figure it out from there. Or we can do a fancy generating function way. So let's write out the first two equations of how this looks. So we have a1 minus 3a0 is equal to 1. We have a2 minus 3a1 is equal to 2. a3 minus 3a2 is equal to 3. So just substituting in some values for n, we get this nice little sequence. And you might be able to see where I was going with this, because we did something pretty similar when we just didn't have a constant by the an minus 1. So this time we have a 3, so if we added things up now, it wouldn't look super nice, but it might be a good starting point. So here's what we're going to do. We're going to do this for every single equation, and we're going to multiply the nth equation by x to the n. So for instance, n equals 1 is going to be a1x minus 3a0x, and this is going to equal 1x. n equals 2 is going to be a2x squared minus 3a1x squared is equal to 2x squared. So we're going to add these all up. And what we see here is we're going to add these up vertically. So we're going to add them up this way. So here's what we get. For, I'm going to do these in different colors so we can keep this separate. Here's all these ones. We're going to get a1x plus a2x squared plus a3x cubed plus ... for the first one. And how can we write this? We can say, okay, this is the sum from I is, well, just the sum of I greater or equal to 1 of ai x to the I. Okay, now let's do this one right here. So we have, well, we're subtracting, but we're not going to keep the subtraction in there. We're just going to add up all of these and worry about the signs afterwards. So these negatives are going to be between the sums as opposed to included in part of the sums. So here we have 3a0 plus 3a1, sorry, this is 3a0 times x plus 3a1x squared plus 3a2x cubed plus ... And this is just equal to, okay, well, this is the sum as I goes from 0 to infinity of ai x to the I plus 1. Because here we have a1 and x squared. And this whole sum is just multiplied by 3. So really, what I just did here was I just factored out the 3 and went from there. In fact, if I wanted to, I could factor out 3x and just say this is a0 plus a1x plus a2x squared, so on and so forth. So I could factor out an x, but I'll leave it in there for now. And finally, when we add up this last column here, what we get is x plus x squared, sorry, x plus 2x squared plus 3x cubed plus 4x to the 4 plus ... And this is just equal to the sum as I goes from, well, that's going to be a 1. So that's I goes from 1 of n times x to the n. So here we have some sums. And these all kind of look like the formal power series of I greater or equal to 0 of ai x to the I. So we're going to do something with this notion. What are we going to do? Well, we're going to set f of x to equal that formal power series. And we're going to solve for f of x by doing some substitutions here. So let's take a look at these one at a time. So in our first case, we have a n x to the n, where n is greater or equal to 1. But the thing is, we want n greater or equal to 0. So this sum is really saying, okay, I have the whole thing, except it starts at n equals 1. So we're missing n equals 0, which is a0 times x to the 0. So we're just going to subtract it. Because if we take a n x to the n, and we subtract the case where n is equal to 0, then it's just the same thing as saying we start at 1. For the next step, what we have here is, well, we have our minus 3, and we're dealing with an minus 1 x to the n. So let's factor out that x now. So now what we get is n greater or equal to 1 of an minus 1 x to the n minus 1. But we can do a really nice substitution here, and we can say, okay, let's let k equal to n minus 1. So this is going to be the same thing if I rewrite this first part, minus 3x. Okay, this is the same thing as the sum of k greater or equal to 0 of a to the k x to the k. And what is this? Well, this is just the definition of the formal power series. So this so far turns into f of x minus a0 minus 3x f of x. And this is going to equal the right side. So what is the right side? Well, let's take a look at the right side here. So n greater or equal to 1 of n times x to the n. Well, what can we do with this? So rather than being a little bit crazy and trying to figure out how we can turn this into a power series, because it's pretty hard, we're just going to write out the generating function for this. So this is x plus 2x squared plus 3x cubed plus dot dot dot. So we can factor out an x. So this is x times 1 plus 2x plus 3x squared plus 4x cubed plus dot dot dot. And we know, if you remember from the derivative section, that this is just the derivative of 1 plus x squared all the way to infinity. So this is just x over 1 minus x squared. So the right side is going to be x over 1 minus x all squared. But that's actually good. Okay, so we're just going to keep this x over 1 minus x all squared. So this is equal to x over 1 minus x all squared. Let me just check to see what I have here. Okay, that's a completely different question. So what do we do now? Well, we should probably put in our value for a0. So f of x minus what? Well, a0, were we given a0? Okay, we weren't given a0 here, but on the first, probably said, yeah, so a0 is going to be equal to 1. So this is going to be f of x minus 1 minus 3x f of x is equal to x over 1 minus x all squared. Take the brackets off. So this is going to be f of x minus 3x f of x is equal to x, and we're going to add 1 to the other side. So this is going to be plus 1 minus x all squared over 1 minus x squared. And now we can factor out that f of x. So f of x times 1 minus 3x is going to be equal to x plus 1 minus 2x plus x squared all over 1 minus x all squared. And now we can group some like terms on the top, so we get x squared minus x plus 1 over, okay, we have the 1 minus x all squared, and then we can move this 1 minus 3x to the bottom. So now we get this solution. So here's the fun part. You remember partial fractions? Well, it's time to do some partial fractions. Okay, so can we factor x squared minus x plus 1 nicely? No, we can't, so let's do some partial fractions. So x squared minus x plus 1 over 1 minus x all squared times 1 minus 3x is going to be a over 1 minus x plus b times 1, or b over 1 minus x all squared plus c over 1 minus 3 of x. Okay, let's make sure these are all over the same denominator now. So we have x squared minus x plus 1 is equal to a times 1 minus x times 1 minus 3x plus b times 1 minus 3x plus c times 1 minus x all squared. So this is going to be a times 1 minus 4x plus 3x cubed. I need to make sure this is right. That's minus x minus 3x. This will be plus b times 1 minus 3x plus c times 1 minus 2x plus x squared. Okay, so let's sort these into their proper powers. So this is going to be a plus b plus c plus, okay, so we have negative 4a minus 3b minus 2c times x plus 3a plus c x squared. So you can see why these problems can be incredibly difficult, because if I make one single mistake here, 1, I have to redo the video, 2, I'm going to be terribly wrong, and 3, I'm going to be extremely frustrated. So very, very long and painful. So what do we know? We can now solve for coefficients. 1 is equal to a plus b plus c. Negative 1 is equal to negative 4a minus 3b minus 2c, and 1 is equal to 3a plus c. So now we have to solve for this. So you might be saying, how do we solve for this? Well, if you know matrices, then you can solve for these fairly easily. If not, you're going to have to do some substitutions. I am going to avoid substitutions and do the matrix manipulation, but essentially what's going on here is I'm just doing coefficient manipulation. That's it. So I'm going to do all of the work that I would with writing out letters in a matrix. So this line is the coefficient of A, this is the coefficient of B, coefficient of C, and this is whatever number it's equal to. So what I'm going to do is I'm going to multiply the second row by negative 1. So essentially I'm going to make those all positive. Now what I'm going to do is I'm going to subtract I'm going to keep row 1 the same, so a plus b plus c is equal to 1. But I'm going to subtract the first row 4 times from the second row. So we're going to get 0a minus b minus 2c is equal to negative 3. And I'm going to subtract the first row 3 times from the third one. So this is going to be 0a minus 3b minus 2c is equal to negative 2. So essentially, this equation became that one, and this equation became the second one, after some manipulation. Okay, so now we want to take the second row, leave the second row the same. In fact, we're going to make these all positive numbers in the second row, because we're going to multiply by negative 1. And then what we'll do is we'll subtract the second row from the first row. So 1 minus 0 is 1. 1. So we're going to add the second. Yeah, we'll subtract the second row. So 1 minus 1 is going to be 0. 1 minus 2 will be negative 1. 1 minus 3 will be negative 2. And for the third row, we're going to add the second row. So 0, 3, negative 3 plus 1 is negative 2. Okay, now we're going to add it 3 times. So that should be 0. Negative 2 plus 6 is 4. Negative 2 plus 9 is 7. Okay, so what we're left with here, sorry if that was a little bit confusing, we're left with 4 over 7 is equal to c, because this last row is saying that 4c is equal to 7. This second row is saying that b plus 2c is equal to 3, and this first row is saying that a minus c is equal to negative 2. So now that we have c is equal to 4/7, we know that b plus 8/7 is equal to 3, which is 21/7. So b is equal to 13/7. Okay, we got those two. And we know that a minus 4/7 is equal to negative 2, which is negative 14/7. So a is equal to negative 10/7. Okay, so what does that mean? That means that we get to plug those numbers back into our lovely partial fraction decomposition up here. So for the first time ever, I'm going to use the copy and paste tool on camera, because this is definitely not super quick. Okay, I'm even going to make it bigger because I can do that. So a becomes negative, okay, wrong tool. This becomes negative 10/7. B becomes 13 over 4. 13 over 4. Why is it 13 over 4? It's 13 over 7. And C is going to be 4 over 7. So we should make sure these numbers do work. So a plus b plus c is equal to 1. So negative 10 over 7 plus 13 over 7 is equal to 3 over 7 plus 4 over 7 is 1. Okay, so no mistakes. Still holds. So now here's the interesting question. Now that we have this, what do we do? Well, this is the generating function for this recurrence relation. So let's take a look at our original question. an minus 3an minus 1 is equal to a0 is equal to 1, and we wanted to solve that recurrence relation. So what we did was we found a generating function for that recurrence relation. So this right here is the generating function. So how do we solve it? We need to take the nth coefficient of this generating function. So this will be the nth coefficient. Actually, we're going to factor out a bunch of stuff. So this is going to be negative 10 over 7 times the nth coefficient of 1 over 1 minus x plus 13 over 7 times the nth coefficient of 1 over 1 minus x all squared plus 4 over 7 times the nth coefficient of 1 over 1 minus 3x. So I factored out the constants, and I'm taking the nth coefficient of each term individually. So if you remember from that video, this will be negative 10 over 7 times 1 to the n plus 13 over 7 times n plus 1, because the nth coefficient of 1 over 1 minus x all squared is just n minus 1, and this will be plus 4/7 times 3 to the n. So essentially, we can simplify this more, and we can say that an is equal to, we have negative 10/7 plus 13/7 n plus 13/7 plus 4/7 times 3 to the n, and we can simplify this to be 3/7 plus 13/7 n plus 4/7 times 3 to the n. And that is the result of our recurrence relation. So here's the magic moment. This is where we test to see if it works. So we had an minus 3 an minus 1 is equal to n, with n greater or equal to 1. So what do we know? We know that a0 is equal to 1. So does this work? Let's check. 3/7 plus 0 plus 4/7 times 3 to the 0 is indeed equal to 1. Okay, perfect. But we know that a2 minus 3 times 1, because a1 is, sorry, solve for a1. a1 minus 3 times 1 is going to be equal to 1. So a1 is equal to 4. Okay, so when we use this recurrence relation, when we plug n equals 1, do we get 4? So a1 is equal to 4. Let's test this out. 3/7 plus 13/7 plus, well, 3 to the 1 is just 3, so plus 12/7. This is very scary. 3 plus 13 is 16, plus 12 is 28/7, and this is equal to 4. So it turns out this is the correct solution to the recurrence relation using generating functions. I'm going to admit something. I didn't write out notes for this, so I had no idea if that was actually going to be right, but the method worked. I did not make an error, so here is the result. On an exam, on my midterm, I gave you a question that was not as long, but still pretty difficult. So good luck. Good luck. Try not to make a mistake. If you need more practice, it's there. There's also this practice question, which I am not going to solve, but I'm going to set up the generating function, the first step. So here's a fast way of doing it. Before we add it up term by term, it takes way too long. Here's what we do. We multiply each term by x to the highest value that you go to. So here you're dealing with n plus 1. So what we're going to do is we're going to take an plus 1, we're going to multiply it by x to the n plus 1. We're going to subtract. We have a to the n, we're going to multiply it by the highest term we have, which is x to the n plus 1. And this is going to equal, so we have 3 to the n, and we're going to multiply it by x to the n plus 1. Then what we'll do is we're going to sum it. We're going to sum each one, and we're just going to take our conditions that we have for n here, and we're going to put them underneath all of these sums. Okay, that's good. And then what we'll do is we're always going to set our f of x to equal the sum, as n is greater than 0, of an x to the n. So let's see what we're missing here. Okay, first of all, in this first step here, we have an plus 1 xn plus 1, which means we're missing a0, because when we start at n equals 0, we get a1 x1. So this first step is going to be f of x minus a0. In this case, we can factor out an x, and then we get an x to the n, where n is greater or equal to 0. So this is just the same thing as f of x. So f of x minus a0 minus f of x is going to be equal to, well, hold on a second, x times the sum, so n greater or equal to 0, of 3 to the n, x to the n. What is this? This is x times the generating function, 1 over 1 minus 3x. Okay, let's solve for this. a0 is equal to 1, so f of x minus 1 minus x f of x is equal to x over 1 minus 3x, which means that f of x, we can factor out 1 minus x, is equal to x over 1 minus 3 of x, and then this negative 1 on the left, we bring to the right. So this is going to be f of x is equal to x plus 1 minus 3 of x, I'm just bringing the 1 on top there, divided by 1 minus 3 of x times 1 minus x. And from there, you can solve yourself, and you will get a result. And of course, you can check your result by plugging in values. So, still pretty long. Definitely long. But much easier than the previous example. And of course, the part that is really the most irritating is solving for these coefficients. This matrix stuff that you've seen, you can do it the long way by just substituting and adding with equations, but if you know matrices, definitely use them because it's going to be much faster. If you want to see a video on that, I don't have one made at the time of the video going up, but it will definitely be done on my channel in the future, so don't worry, that'll be done. So that was the setup for that one. And because now we're done, we've done all the material up to my mock midterm 2. So if you check out Discrete Math 2, midterm 2 at TrevTutor.com, it covers generating functions, combinatorial families, and recurrence relations. This is a almost real midterm taken from a real university. I say on the exam that the average was 47% on the midterm, so it is real difficulty. Like, it is a real exam. This is something that was taken by 280 students at a real university that is pretty highly ranked, and it covers everything that I did in my videos. So that's where I got the inspiration for these specific videos, and I really hope you can do well in those. If you have any questions, you can leave them in the comments below, or you can check out TrevTutor.com for some more information on how to contact me. We also have a subreddit at reddit.com/r/TrevTutor. And if this helped you, share it with your friends because this might help them too. So there will be a solutions video for midterm 2 as well, so look forward to that. Anyways, hope you guys have a great day. Next time we start the third section, which is graph theory.